Well, welcome back to another topic on rational exponents and their properties. Exercise 1. Write each expression in exponential form. So I want you to highlight for yourself this word exponential form, and you can see the word exponent right in there. Our answers have to have an exponent in them. So let me remind you of the rule that we just talked about. We said b to the m over n is equal to the nth root of b to the m. Okay, so again, the name of the root, I'm going to circle it, is always in the denominator. So we said think of like a plant. The roots grow in the bottom. So the name of the root is in the denominator. So what you could probably do for yourself is pause it, write down A through F, and then we'll quickly go over them. So then I would pause it so you're ready to roll. Here we go. Letter A. This is the cubed root of 2. So how am I going to rewrite that for myself? Hopefully you're already ahead of me, and that's 2 raised to the 1/3. Again, the name of the root goes in the denominator, and this is really raised to the first power, so 2 to the 1/3. Notice in B, they don't have the name of the root. Well, you know it's called a square root, square meaning the number 2. So they're never going to put a 2 there for square root, so you're assuming that you understand what a square root is. So I'm going to say this is 10 raised to the 3/2, square root on the denominator. I'm going to say this is x to the 5/4. Hopefully you're with me. Again, the name of the root in the denominator. Now, of course, they're going to get a little uglier. Notice here, this is the cubed root. So the root's going to go in the denominator, and all of that's under there. So to show the reader that you understand that all of it's under there, we're going to put parentheses around it. So that's 6x raised to the 4/3. Now let's go one step further. Because there's parentheses, everybody inside here has to get raised to the 4/3. So we want to rewrite this as 6 to the 4/3 and x to the 4/3. Every term gets raised to the 4/3. Letter E, again, they don't have the square in there. It is called a square root. And again, everybody in there is raised to that power. So I'm going to rewrite it with parentheses, raised to the 1/2. Okay, again, square root, 2 goes on the bottom. And then I'm going to separate. Everybody in here gets raised to the 1/2. So 3 to the 1/2, and let's review. Power to a power says you're going to multiply. Now, of course, you have a calculator and you can multiply, but you should be able to multiply fractions in your head very quickly. All I do is I put the denominator over 1, and I multiply the tops. On top, I get 3. On the bottom, I get 2. So that's a to the 3/2. Now, lastly, you can get a little extra negative with these negatives. So the first thing I always do is I make it positive. To make something positive, you just move it to the denominator. So I'm going to rewrite this as 1 over the square root of 3x to the 5th. And then I just moved it to the denominator. So now I'm going to say, okay, that's really 1 over, this is a square root, so 3k to the 5/2. And again, I'm just going to simplify by giving everybody that power. So that's 1 over 3 to the 5/2 and k to the 5/2. So hopefully just a nice quick review of what we should be comfortable with already. So again, I would pause it and get this table copied down and then turn it back on so we can talk through it together. These are the exponent rules that you should know. Obviously, we should know them from Algebra 1, and we've already reviewed them all in Algebra 2. So let me, again, quickly talk through them. When I multiply, I add the exponents, keep the base. When I divide, I subtract the exponents, keep the base. Power to a power says multiply. Negative exponents move to the denominator. When you have parentheses, every term gets raised to that power. Whether it's multiplying or dividing, every term gets raised to that power. And any term to the 0, of course, is 1. So carefully examine the directions here. The difference between the two questions. So I want you to take a look at these two questions. They are exactly the same term, meaning I should get the exact same answer. I'm just going to solve them differently. And that's the key. We have to be able to solve things in multiple ways. So the first one, notice it says in simplest radical form, and just highlight that in your notebook. Most people are pretty good at simplest radical form, so let's just kind of quickly review what we would do. Now the only catch here is that it's not a square root, it's a cubed root. So I need the cubed root of negative 27. I'm going to go the cubed root of x, the cubed root, and the long way was to write these out. You have 7y's. Some people caught on a little quicker and have a little cheat method. I have 6 z's, and I had 1x. But just remember, that's all a cubed root. So when I go to break this down, I'm saying, is there a cubed root of negative 27? So remember, I'm saying, are there 3 numbers that exact same that multiply and get me a negative 27? Well, 3 times 3 times 3 is 27, and a negative, negative, negative makes a negative 27. So I'm going to say that's negative 3. I cannot break down the cubed root of x, so that's going to stay as cubed root of x. Now the y's, because it's a cubed root, I'm looking for multiples of 3. There's 1 I can pull out. There's 2, so that's a y squared, because I can pull out 2 of them, and I have 1 y left over. My z's, I can pull out these 3, that's 1. I can pull out these 3, that's 2, so that's z squared, and I have none of them left over. So let me just write this a little neater. I end up with negative 3 y squared z squared, and then I have the cubed root of xy. And again, most people are pretty good at that. Part B says express this a little differently. Express this with rational exponents. Okay, rational exponents, maybe underline for yourself, means you need a ratio, a fraction. Okay, no radicals. You need a fraction exponent. So what am I going to do? Okay, I'm going to say, well, all of that is under the radical, so it all gets raised to the 1/3 because it is a cubed root. And now I have to say, okay, everybody inside here gets raised to the 1/3. Negative 27 raised to the 1/3. X raised to the 1/3. Y to the 7th raised to the 1/3. Z to the 6th raised to the 1/3. And now I can go through and simplify that. This again really means the cubed root of negative 27, which is exactly what we had here. So we know that's negative 3. X to the 1/3 I can't break down, so I'm going to leave that as x to the 1/3. I'm going to multiply my exponents, so I get y, remember that's over 1, to the 7/3. And again, I'm going to multiply my exponents, 6 and 3, so I get z to the 6/3, which is, of course, is really z squared. Okay, so I'm going to keep cleaning this up a little bit. Now, I know I'm supposed to get the same answer because it was the same question. Right now, this answer and this answer are not looking the exact same. I have the negative 3's. I have the x to the 1/3 is the cubed root of x. Right here, 6 divided by 3 becomes 2, so there's my z squared. Okay, so I have x to the 1/3, which is the cubed root of x. I have z squared. Now, what about this guy? Well, here's what we do. We say 3 goes into 7 how many times? It can go in 2 whole times, and I'm left with how many? 1 left over. So 3 goes into 7 twice, and I have 1 left over. So now remember, my goal wasn't to write these with any radicals. I really end up with negative 3. I have a z squared, a y squared, and then here I have a x to the 1/3 and a y to the 1/3. All right, let's try another example, very similar, and we want to write with positive rational exponents only, so no radicals. So again, I'm going to go with the method of rewriting all of this raised to the 1/4 root. Okay, now I'm going to use my power to a power. Remember, this 16 actually has a power. There is a 1 there. So I get 16 raised to the 1/4. I get a to the multiply, negative 12 over 4, b to the 2 over 4, and c to the 6 over 4. Technically, this answer is almost perfect. I just have to make sure I have all positive exponents, and then I'm going to clean it up just because they're probably going to do that on the exam. So 16 to the 1/4. So I'm looking for the 4th root of 16. Are there 4 numbers that multiply to 16? Of course there are. That would be the number 2. This is really a to the negative 3rd, b to the 1/2, and c, I can divide those both by 2 to the 3/2. Now the only catch was that I needed positive exponents. So how do I get positive exponents? Well, anybody that's negative just moves to the denominator. So I can leave the 2, the b to the 1/2, and the c to the 3/2, and I'm just going to move the a cubed to the denominator. Exercise 3. Rewrite each expression in the form kx to the n, where k is a real number and x is a positive number, and here's the key, n is rational. Okay, so again, it has to be a ratio, no radicals, fractions we're looking for. So it's really just about that rewrite step, guys. I'm always going to go 81 raised to the 1/4, x cubed raised to the 1/4. And what does that mean? Are there 4 numbers that you can multiply to get 81? Well, of course, 3 times 3 times 3 times 3. So the 81 to the 1/4 is 3. Now, can you type that in your calculator and get the same answer? Of course. So don't stress out if you didn't have that off the top of your head. Here, I'm going to multiply my exponents. I get x to the 3/4. Multiply the tops, multiply the bottoms. Here I have 5 over x to the 1/2. Where did the 2 come? It's called the square root. Now, you could bring that up to the top and call it 5x to the negative 1/2, but the direction said x has to be a positive real number. So I'm actually going to leave it like that. Here I'm going to go the cubed root. So I'm going to say 1 to the 1/3 all over x to the 4th to the 1/3. Now 1 to any power is just 1, so I get 1 over x to the 4/3. And I'm just going to leave it like that. X is a positive root. On this next page, I'm only going to do question D here. So again, I'm going to rewrite this as 4 over. I just do lots of baby steps. Everybody there is going to get raised to the 1/3. Negative 8 x cubed raised to the 1/3. Now I raise everybody inside those parentheses to the 1/3. Negative 8 to the 1/3, and then x multiply is going to get me a 1. And again, I'm just going to keep cleaning it up, just baby steps. Negative 8 to the 1/3 is really, in my head, the cube root of negative 8. Are there 3 numbers that are the same that can multiply to negative 8? Of course they are. Negative 2, negative 2, negative 2. And I get my x, and then I can divide these two numbers and say that's negative 2 over x. Why is the x still in the bottom? Well, 4 divided by negative 2 is negative 2, and the x, that's where it was, so I'm going to leave it in the bottom. Now I can bring it up to the top if I want, but then I would just make that exponent a negative 1, because currently it's a positive 1, and to bring it up I would just negate it. From these two examples, I'm just going to focus on question H, because it's a little ugly looking and a little intimidating, but we're bound to see it. So notice there's 2 roots, and they could put as many as they want in. So I'm going to take care of the first one. That is the 4th root. So I'm going to put a big set of parentheses and raise that to the 1/4. Now I'm going to take care of this. That's to the 1/3. And what's all to the 1/3? 4096x. So let me just be clear on what I did. I have my 4096x. I see the cubed root, so that's raised to the 1/3. And then all of that is under the 4th root, so all of that gets raised to the 1/4. Now, it's actually quite simple. We just have to clean it up with our properties. The first property I notice is the power property. So I'm just going to multiply my exponents. So I really get 4096x raised to the tops make a 1, bottoms make a 12. So all I'm going to say is that everybody in there gets raised to the 1/12. So this is 4096 raised to the 1/12 and x to the 1/12. And we're done. Now our exam is very big on the word explain. When they say explain, you have to have a sentence. Let me be very clear. It has to be a sentence on how this can happen. So they said, explain how negative 8 to the 4/3 can be evaluated using properties of rational exponents in an integer answer. So yes, you could type that in your calculator, get an answer, and write it down and think you're going to get credit, but it's not going to be true unless you have an explanation. So feel free to type that in your calculator so you know what answer you're shooting for, and then we're just going to talk it out. So I'm going to show math, and then I'm going to write a sentence with it. So they have parentheses around this negative 8, which means all of that gets to the 3rd root. So I'm going to say this is the 3rd root of negative 8, and all of that is to the 4th power. Okay, so hopefully we're on the same page there. It's just that same property. The root goes on the bottom, so it's the cubed root or third root of -8. That's what's in the parentheses to the fourth power. Now it doesn't matter what you do first, if you take the cubed root first or if you raise it to the fourth first. In my head, I can take the cubed root of 8 easy, so I'm going to say the cubed root of -8 is -2. And then I'm going to raise all of that to the fourth, which really means -2 times -2 times -2 times -2. And I get a positive 16. And they're saying, now explain how that can be an integer result. So all I'm literally going to do is write a sentence saying what I did. So in English, I would say, I took the cubed root of -8, so I'm writing that out on my paper, which I got -2, and then I raised it to the fourth power to get 16. And that's all they're looking for. Just explain in words what you did. All right, example number 2. So here again, it looks ugly, but just step by step will make it easy. So all of this, a to the 7th b cubed, all over 32a squared b to the -7th, all of that squared is now getting raised to the 5th root, which means 1 over 5. Okay, so all I did was apply that first property. Now I'm going to do my power to a power property and clean it up again. So that's a to the 7th b cubed, 32a squared b to the -7th, and the power property says that becomes a 2/5. Now I'm basically going to use the power property again. Everybody there is going to get raised to the 2/5. So I'm going to do 7 times 2/5. So that's a to the 14/5, b to the 6/5. Okay, all over, don't forget the 32, raised to the 2/5, a raised to the 4/5, and b raised to the -14/5. And again, I just multiplied my exponents. Multiply the tops, multiply the bottoms. Okay, so now I'm going to apply another property. When I divide, I subtract the exponents. The a's are the same. So off to the side, I'm saying 14/5 minus 4/5. Common denominators, already have them. So that's going to be a to the 10/5. Let's do the b's. 6/5 minus -14/5. Two negatives make a positive. That's 20/5. Okay, now notice where the 32 to the 2/5 is sitting. It's in the denominator, so it's going to stay there. 32 to the 2/5. And I'm just going to keep cleaning it up. 10 over 5 is actually 2, so I get a squared. 20 over 5 is 4, b to the 4th. All over, I need the 5th root of 32, and then square that. So what's easier for you, squaring 32 or taking the 5th root of 32? Well, I can do the 5th root a lot easier than squaring 32. The 5th root of 32 is 2, and then 2 squared is 4. So I got a final answer of a squared b to the 4th over 4. The second part of the video is on solving rational equations. So here are your 3 key steps. Isolate the term with the exponent or root. Take the inverse of the term, and then of course check. So pause it, get those down, and when you're ready, turn it back on. So here's example 1. 12 equals 4n to the 1/4. Now I want to remind you, this 1/4 is not on the 4 and the n. There are no parentheses there. So box it in. This 1/4 is only on the letter n. So step 1 was to isolate the term with the exponent or the root. So I'm going to first, it says 4 times n. I'm going to get it by the n to the 1/4 by itself by dividing both sides by 4. So now I have 3 equals n to the 1/4. So here's what you can do for yourself. Remind yourself of those rules. The 1/4 is really the 4th root of n to the 1st power. So if it was a square root, how would you get rid of a square root? Square both sides. Same idea. If it's a 4th root, we're going to raise both sides to the 4th power. So the 4th root and the 4th power cancel each other out, because they're inverses. So here you just get n, and here you get 3 to the 4th, which is 3 times 3 times 3 times 3. Well, 3 times 3 is 9, 3 times 3 is 9, therefore n equals 81. And can you quickly throw that in your calculator and check? Of course. Okay, let's try another example. Negative 3 plus 4x to the 7/5 equals 509. So the thing you're asking yourself each time is, who is the exponent or root sitting on? Since there are no parentheses boxed in, the 7/5 is only on the x. Only the x. Okay, so now my goal is to isolate that, get it by itself. What would I do first? Hopefully you're saying you would add over 3. Again, just some basic algebra skills. So I have 4x to the 7/5 equals 512. Okay, so I'm going to box it in again. The 7/5 is only on the x. Now my goal is to divide by 4. So my 512 divided by 4 gets me a 128. So again, I'm just going to rewrite this for myself. This is the root goes on the bottom, the 5th root of x to the 7th equals 128. Okay, so again, if it was a square root, I would square both sides. It's a 5th root. I'm going to raise both sides to the 5th power. Now, I'm not going to really do that. I'm just going to write it that way. So I get x to the 7th, the 5th root and 5th are inverses, they cancel each other out, equals 128 to the 5th power. Okay, so now I still have to get x by itself. How do I get rid of a 7th exponent? I take the 7th root. I'm going to take the 7th root here. Those are inverses, they cancel, and I just get x. Now remember, I do the one that's easier first. Can I take this to the 5th power in my head first, or do I do the 7th root first? Well, I can do the 7th root in my head a lot quicker than I can take 128 to the 5th. I'm just looking for 7 numbers that multiply to 128. And you can hit the 7th root button on your calculator. I get 2, and then 2 to the 5th, of course, is 32. Now again, you have a calculator. You can just simply type that part in when you get to that point. Alright, last example here. My goal is to solve for b. Now notice there are parentheses. So this b term, I want you to box in by itself. Our goal is to get that by itself first. So order of operations, again, simple algebra from 8th and 9th grade. I'm going to subtract over 8 first. I'm going to get 2 times b plus 12 raised to the 5/4 equals 64. Okay, this is I have to isolate that term, so I'm going to now, that says 2 times that quantity, divide by 2. So I've got my b plus 12 raised to the 5/4 equals 32. Now how do I isolate that? Well, I'm going to rewrite this. This is really the 4th root of b plus 12 to the 5th equals 32. Okay, so how do I get rid of a 4th root? Again, the inverse of a 4th root is to raise it to the 4th power. Whatever I do to one side, do to the other. Those eliminate each other. So now I have b plus 12 raised to the 5th equals 32 to the 4th. Now again, I'm not going to do that because that takes me way too long. I'm just going to keep going. To get rid of the 5th power, I'm going to take the 5th root. And I'll take the 5th root over here. So I have b plus 12 equals, now again, what's easier, the 5th root or 2 to the 4th? Well, I can easily find 5 numbers that multiply to 32, which of course is 2 to the 4th. 2 to the 4th is really 2 times 2 times 2 times 2, which is 16, equals b plus 12, and now I can subtract over my 12 to get b equals 4. And of course, you can easily go back and check.